Everybody, so welcome to kind of our explanation for the first homework. I'm going to be going over everything we've gone over so far, as well as explaining the solution to the Hailstone problem, as well as kind of taking a preview of rock, paper, scissors, which is going to be our first game, and we're probably going to intro that sometime next week. So let's get started. Okay, so in homework 1, we had a couple questions. Okay, and that includes our first question, which was a plus abs b. And what this question is essentially asking us is to take some number a and some number b, and we want to always take the absolute value of b. So, in this example, we see how 2 plus the absolute value of 3, and that becomes 5, right? Okay, so this is 2 plus 3. Okay, and this is 2 plus the absolute value of negative 3. Okay, so that's 3, and that's also equal to 5. Okay, so the question asks for us to basically assign something to f, and we know it has to be a function because this is a function call, so we have to apply something to a and b, and basically we know it's also add and subtract right here. Basically have to be assigned to f, and it's going to depend on what the value of b is. Okay, so add or sub, we don't know which one it is. Okay, and the same thing down here, add and sub. So basically what we want to do to approach this question is take a look at the test cases we have and try to account for them. Okay, so let's take a look at the first case. Okay, so if 2 comes in as a and 3 comes in as b, I'm going to go into this if, right? So is b less than 0? Is 3 less than 0? No, so we're just going to go down here, okay? And then what should we do? Well, we have 2 and we have 3. What do we need to do to get it to 5? We need to add them, okay? So that wasn't too bad, yeah. Now let's take a look at the second case. A plus abs b. 2 comes in as a, negative 3 comes in as b. So if b is less than 0, what is b? It's negative 3. So is negative 3 less than 0? That's correct. Okay. So we're going to come inside the block and say f equals add or subtract. Well, I have 2 and negative 3, and I need to get to 5. And I know that 2 minus negative 3 equals 5 because these two negatives cancel out. Okay, so basically what I'm going to end up having is addition all over again. And that is how you're supposed to kind of figure it out. Okay, you could try addition, right? You could do, but what does that equal? That doesn't equal 5. That equals negative 1. Okay, and negative 1 is obviously not equal to 5, right? So we know it can't be add. Then we test subtract, and we find that to be the correct answer. Okay. 2 of 3 was all about understanding that we have 3 numbers coming in, okay, and we want to find the biggest combination of them, okay, and so we're going to take the top 2. Now, you could do this with a bunch of ifs, right, and we tried that, but it turns out that if you see that there are only 3 combinations, right, there's AB, there's BC, and there's AC. These are the 3 possible combinations of 2 that I can get from these 3 numbers, okay? And I just want to calculate what that is. So AB is going to be A times A plus B times B, okay? BC is equal to B squared plus C squared, okay? And AC is again equal to A times A plus C times C. And these, all 3 of them are the same thing, okay? And that's just the operator for putting stuff to the power of this number, okay? So I now have these, and I want to check with if statements. Okay, so if AB is greater than BC, and AB is greater than AC, well, that means AB has to be biggest, right? AB is the biggest. Yeah. So I'm gonna print out AB, or I'm gonna return AB because that's cooler. Okay. Else if what? Well, let's check if BC is the biggest. Okay, if BC is bigger than AB, and BC is bigger than AC, right? What should I do? Well, I've just found that BC is the biggest. Okay, and if we find that AB is not the biggest, if we didn't go inside there, and if we didn't go inside there, well, then we know AC is the biggest, because it has to be, right? I could do another else if, but it's kind of redundant. Okay, so that's the way of doing it with if statements, and that's the way of doing it with a max function, which is built into Python. So those are cool. And we can test this using the examples given, okay? So let's just try it for this one. This seems like a nice edge case. Okay, so 5, 5, 5. 5, 5, 5 come in. AB is equal to 50. 5 times 5 plus 5 times 5, okay? BC is also equal to 50. And AC is also equal to 50, okay? So if AB is greater than BC and AB is greater than AC, what should happen? Well, let's see. Is AB greater than BC? Is 50 greater than 50? No. So we don't even need to worry about this because we already evaluated to false. If one of them's false, we're not going to go inside. Okay, so we're going to go down here. Is 50 greater than 50? Nope. So we hit this else, and we're just going to return AC. And that's right, because we have 50, and that's the square of the sums of the largest two. Okay? And obviously, you can go through the rest of the examples on your own. Okay, we're just going to skip question 3, because it's kind of useless. And then Hailstone, sorry, which is the last question I gave you. Okay, so let's delete this. Okay, so we want to print the Hailstone sequence starting at n, so n is coming in, and returning its length. Okay, so basically how many iterations we went through. Okay, so any question that asks you to do some kind of computation, you should always consider while loops, okay? Yeah, I can give you, I know one example that I saw that was wrong was this. N is equal to 5, n is equal to 15. Okay, and the reason that this is wrong isn't so much to do with, sorry, this is 16. Isn't so much to do with anything syntactically, but that's wrong too. But basically, it's the wrong approach, right? I should be able to do anything with this function, right? I should be able to give it any number, whether that be 10, whether it be 200, whether it be 200,000. This function should be able to calculate it for anything, okay? And for that reason, it needs to be versatile for all of them, okay? So I'm never going to use actual numbers in the function. That's not a thing, okay? What I am going to be using is a while loop that refers to n without me knowing what it actually is, okay? I'm just going to think of it as n, okay? But it really could be anything. But I do have a mathematical formula that's given to me, okay? So pick a positive integer, n is the start, okay? So I have that. If n is even, divided by 2, okay? Well, how do we check if something's even? It's the modulus operator, and we check if it's even by checking that there's no remainder, right? And what happens? If n is even, divide n by 2. N is equal to n divided by 2. Alternatively, this is the same thing as calling this, okay? They're both the same thing. And yeah, that's pretty simple, okay? And if it's not even, well, then it has to be odd. And so what do we do if it's odd? Well, if it's odd, we need to multiply it by 3 and add 1, okay? So 3 times n, okay, let's do n equals 3 times n plus 1. Okay, simple enough so far? and it says continue this process until n is 1. Well, okay, so how would I continue a process? Basically, what we've seen so far is that the only way to continue a process is by using a while loop, okay? So while something, right, something, I want to put this inside my while loop. And my indentation is all screwed up, so make sure you get all of that. I have my colons and stuff, so you're running into syntax errors. Make sure you fix that up. Well, okay, what's this something? Continue this process until n is 1. Okay, so until n is 1. So we want to continue or do this process until n is 1. And how do we check that? Well, while n is not equal to 1, I want to keep going. Okay? And so we're gonna say let's just look at this example. Okay, so 10 is gonna come in, and we're gonna look at the conditional, right? The test condition, and say is 10 equal to 1? No, so we're gonna go inside. And then we're gonna say is 10 divisible by 2? If so, do something. So it turns into 5. Okay, and then we just skip this else box. We come outside, and we go back again. Is 5 equal to 1? Nope. So then what happens? I'm going to go in. Is 5 divisible by 2? Nope. It's not even. It's odd. So we go here. And what's 3 times n? It's 15. Plus 1 equals 16. Okay? So my new n is now 16. Okay? And I'm doing some computation on an n that gets it closer and closer to 1. And you don't have to know that this is like always true, right? I'm telling you over here that if you start with any number n and you do this formula, it'll always end up at 1. Okay? So now I'm at 16. Is 16 1? No. Is 16 divisible by 2? Yes. What is n now? Well, 16 divided by 2, so it's 8. Okay? I come outside. Is 8 1? Nope. I'm going to go inside. Is 8 divisible by 2? Yes. What is 8 now? 4. Okay? 4 will soon become 2. Will soon become 1. And that's it. Okay? So, what do I need to do? This is the basis of the logic, but how do I get this exactly? Well, the first thing we need to do is make sure that we're printing it out, right? So, I need to print out n every time, okay? And what that'll do is I'll print out n the first time, right? And then I'll get all the way down to 1. And when I get to 1, I'm actually going to have to put a print outside here. Print n. And why is that? Well, we did our whole example, 4, 2, 1. And so when we got to 2, right? Well, n is 2 right now. So it goes inside here, and what does n become when it's 2? It's 2 divided by 2, n becomes 1. Okay, then we come outside, we see, well, is 1 not equal to 1? No, that's a false statement now. It turned into a false statement, so we're going to break outside the loop, and because of that, we're not going to get to print out 1 at the very end. So we just need to make it here, okay? If you got close to this, or you just forgot this part, don't worry. It's what testing your code is for. And if you're having trouble testing your code, go ahead and take a look at Python Tutor. Okay? And then the second thing we need to do is return the length of the Hailstone sequence. So 10, 5, 16, 8, 4, 2, 1. Okay, and so how do we do that? Do you guys have any ideas? Well, something called a count variable is very useful when you have while loops. Okay? And basically what I want to do is every time I print something out, I want to make count go up 1 because it means I'm iterating once through the loop every time I printed something out. Okay, and I should probably just do it down here as well because I'm printing again the number 1, so I need to do it here too. Okay, and the other alternative to that is just starting count at 1. Usually you start count variables at 0. Okay, but you can start this at 1 because you're going to print it later. But we're just going to leave this count variable down here. Okay. So what we've done is now we have the count, and how do we get this? How do we get A to have it? What should we do? We should return its length. Okay, so what's its length? Well, we just return count. Make sense so far? If you have any questions, please post them. Otherwise, let's move on to your first game, okay? So I'm just going to do a quick preview of rock, paper, scissors, what it is, how to play it, and how we can do it computationally in code, okay? So I'll give you guys a more advanced heads up tomorrow when I post another video on getting started, okay? But essentially, with rock, paper, scissors, you're going to have some user choice, okay? And so what is user choice? Well, it's something that the user has chosen, okay? And it's their choice of either, and it can be chosen, and it's a string. It's a string, and it can be either R, P, or S for rock, papers, or scissors. Okay, and basically what we are in charge of doing is writing a function that generates a random computer choice. So we're going to build an AI that generates something random, generates a random choice, and basically allows the user to play against this rock, paper, scissors function. Allows the user to play paper, scissors function. Alright, so let's just think about the game first, okay? So if I choose rock, I beat what? Paper. Sorry, scissors. If I choose rock, my choice. Okay, we'll just say user choice. User choice. And AI. Okay, so if I choose rock, I beat scissors. If I choose scissors, I beat paper. And I split that up. Okay, and if I choose paper, and the AI chooses rock, then I win. Okay, so these are basically the three possible scenarios. And then, of course, if you choose the same thing, you tie. Does that make sense so far? Okay, so I have a user choice and I have an AI choice. Oops. Okay, and if we choose the same thing, we tie. But otherwise, there are basically 4 situations. Okay, and how do we generally approach something where there are multiple branches, where I can go that way, or I can go that way, or I can go that way, or I can go that way? Well, if statements, right? So if I chose rock and they chose scissors, then what? Then what should I do? Think about it. Think about it. Pause the video if you don't have an answer. I should win. But what if I chose scissors and they chose paper? Well, I should win. What if I chose paper and they chose rock? I should win. Okay. What if we tied? What if we chose the same thing? Well, we should tie. And if I didn't win, these are all the 3 situations I could win in. this is the one situation we could tie in, where we chose the same thing. If I didn't win, and I didn't tie, well, I should lose. Hopefully that makes sense, and if that doesn't make sense, post a question, or take a look at this a little more and think about it, okay? So this is going to be the basic structure of your function, okay? And this is rock, paper, scissors, computationally, okay? So I'm going to post something tomorrow, but I just want to give you a quick preview of what this looks like and what other languages look like, okay? So don't worry, I'm not going to make you learn this, but it's going to be kind of cool for you guys to see rock, paper, scissors in another language. Where is it? I highly recommend being very organized, because I'm not organized. Here we go. Alright, don't worry about all this. Don't worry about all that. Alright, so what's going on in here? It looks so complicated. Okay, that's what the comments are for. Alright, so let's talk about what's going on here. So basically, this is rock, paper, scissors, and it gets some selection. Okay? You don't need to worry about what this actually means. Just follow along, okay? So we're going to define a number choice relationship where rock is basically going to be equivalent to 0, where paper is going to be equivalent to 1, and where scissors is going to be equivalent to 2, okay? And then we're going to feed that into a function like the one we're making. Okay? This is the function. And let's try not to scare you too much. This is Java, so it's not as clean as Python, but it's very powerful. Okay? So what is this doing? Well, I'm making a new random. Okay, whatever that means, alright? And then I want to make a random number between 0 and 3. Okay, so this is all it's doing is making a random number between 0 and 3. Does that make sense so far? And then I want to print what I picked. So I picked whatever this means. Okay, what does that mean? Well, I'm taking my random number that I picked and checking to see what it was. So if I picked 2, for example, what would I expect? I would expect it to print out, I printed out scissors. I picked scissors, okay? If my random number was 0, I picked rock, okay? And here is my if statement, else statement thing, okay? So the opponent number is coming in, and if you're completely blown away right now, just go back, chill, don't worry, this is more complicated and completely, it's totally ahead of you guys, so don't worry about that, okay? Just make sure you're just, like, following along, okay? So somebody's opponent num, what is that? Their choice coming in, okay? So it's between 0, 1, and 2, and basically it's their choice in number form, okay? Instead of an RPS, it's 0, 1, or 2. And what I'll have you guys do is, again, generate a random number and convert the user's rock, paper, or scissors into a number, okay? And then do battle with that. You should know what they mean. Okay, so if we chose the same thing, it was a tie. There are a couple losing situations. So 0 and 2, which is rock and scissors. Okay, so the user will lose and the computer will win when the computer chooses rock and the user chooses scissors. When the computer chooses paper and the user chooses scissors. And when the computer chooses scissors and you choose paper, okay? So you'll lose in all those cases. Don't worry about this, completely useless, losses and stuff, completely useless, okay? Otherwise, so if I didn't tie and I didn't lose, well, then I won, okay? That's a little different from what we did over here, but it's pretty much the same. Where is it? Okay, it's pretty much the same. So what I did was, instead of saying rock versus scissors, I put it to a number. And if you look back at it, I did something where I checked the difference between our numbers. and this just means or. Okay, so the difference between our numbers was either 1 or -2. It means you lost. And okay, so a quick bit of computation. We're going to go ahead and do this. If you don't understand what I did with the whole differences, that's more advanced. Don't worry about it. This is basically the whole structure of the function. So if you feel confident at the moment, even though I haven't formally assigned something like this, go ahead and finish this rock, paper, scissors function, okay? And then we'll talk about how to make this a full-on game. But basically, you need to generate a random number up here, number, basically the AI's choice. Okay, and then you should run this whole deal. And this is just pseudocode, okay? So I forgot colons and stuff. This is obviously not proper syntax. But yeah, so that'll be the basis of that, okay? So thanks for watching, and that is good.